This is a video showing examples of how to select, cut, and paste a text table of data, numbers usually, into Python source code that works using the Emacs code and text editor. This here is Emacs. It is a popular editor originally from Unix. It's available on Macs. It's available on Windows. This is a Windows 10 computer, and I'm using version 27.1. All this information here. Let's go back to my text. So here I have a table of data. This is actually cut and pasted from a website. It could be from an email. It could be from a document, a PDF file, many different sources where you want to quickly cut and paste and analyze some data. Now, one of the problems with the standard selection that you have in most editors like Emacs is it will select not just the table data you want, but other text around it. Whereas all we're really interested in is this rectangular region here, which again, is how do we select that? In Emacs, there's 2 to 3, depending on your version of Emacs, built-in ways to do this. You can do it manually by hitting Meta X and then entering a built-in Emacs command, rectangle mark mode. And I will note that the meta key is usually the escape key on most keyboards. On my Windows keyboard, the escape key is in the upper left corner. So you hit escape X and then you can enter these Emacs commands. So let's go into the rectangle mark mode. I'll illustrate it. So you can see it selects just a rectangular region. I want the entire table, so I do this. And then I can use either the menu I could copy, or I can use the hotkey for it. Let's do that again, just to show how this works. Again, we do what would be escape X on most keyboards. We're going to bring back the rectangle mark mode. We go into the rectangle mark mode and we go here. Okay, and so we could use the copy feature here, or we can use the hotkey, which is escape W. We can also go into the rectangle mark mode. Almost all versions of Emacs have a shortcut key for it where you do Control X and hit the space bar. Again, we're back in the rectangle mark mode. We do that. We select the mode. Again, we could use the menu to copy, or we can use the faster escape W or meta key W, which is almost always the escape key. So that's these two here. My Emacs I have set up to allow me to use the mouse, so I can hit the shift key and drag, and you'll see it drags now to select this. Okay, so again, I will copy it, and I could do that with the menu, or I could do that with the escape W. Let me just show how I set up the mouse drag. So what we can do in Emacs is we can go to tilde is a abbreviation that Emacs has for the startup folder where it first starts up, slash .emacs. .emacs is the startup file, and here we have the code that sets up a function to do the mouse drag and binds it to shift. S is the shift key, down mouse, so that's the leftmost mouse button on mouse button 1, leftmost mouse button on my mouse. Actually, I use a trackball, but they're basically the same. All right, so at this point we have this table in the buffer, in the copy buffer. So now we want to put it into working Python code. Let's go here. And I have here a little cheat sheet about exactly what to do. Now you could probably automate this with a Emacs function that you set up in the .emacs file, for example, which you could either invoke through escape X or bind to a key. A later video I may show how to do that, but I just want to show you if you have kind of a vanilla setup with Emacs, you don't have all this fancy add-ons, how would you go about doing this? Well, here I want to get that data into a usable data structure, a numerical array in Python. So NP is an abbreviation that's usually used for the NumPy package, which is fast numerical arrays that make Python comparable to MATLAB and even compiled languages like C or C++. And it has a lot of other things. It has all sorts of standard functions, random number generators, all kinds of stuff that you might use for data analysis. And matplotlib, which I'll show down here, matplotlib is a package which gives Python MATLAB like plots and graphics. So MATLAB is a very popular, it's the second most popular numerical programming commercial tool. It costs a lot of money to get it. There are free clones of it like Octave. But anyway, the point is you can duplicate the MATLAB capabilities with Matplotlib. Okay, so far. Now, what we want to do is convert a Python list of lists into an actual table of data. So lists are started by an open square bracket and ended by a closed square bracket. That would be an empty list. This would be a list consisting of the integer 1. This would be a list of 1 and 2, etc., etc. All right, so let's now paste here. I'm going to do it with the menu. Now you're going to see a problem here, which I want to show just to understand the issues. Hit paste, and you can see it proceeded to sort of overlap the code I already written. I obviously don't want that to happen, so I undo, and I add some room for the rectangle paste to have a place to paste in. Okay, so we're going to do it again with the paste, but this could be just Control Y, the yank, and there we are. There's our data. Now this is not usable in Python to do, in this case, a graph or data analysis like fitting a function to it. So we need to make some additional changes, which I illustrate here. I'm going to do it very explicitly for now. I want to select this data. I don't need to use the rectangle select, although I could at this point. And I want to replace the underscore, not the underscores, the commas, the thousand separators, because Python won't understand those. So let's do query, replace, regex. These are, regex is a shorthand for regular expressions in the Emacs environment. Here we go. So we want to convert that comma to an underscore, which Python will accept. It uses these as a kind of thousand separator, or in fact, I don't think it has to be thousands, for numbers in the code so the code is easier to read. First thing we have to do is done. The next step, and actually let me do Control X space, I'm just going to select the table itself to avoid goofing something up. The next step, I will do Escape X. I'm just going to use up arrow to bring back the query replace regex, so I don't have to type it all out again. There we go. The next thing I want to do here is enclose each row in square brackets so it becomes a list. What we're trying to do is convert the table to a list of lists in Python, which then the nparray function will convert into a numerical array that Python understands. So the next step is /paren, that sends a paren. It's a grouping and recognition symbol in the regular expression. Dot stands for any character except the new line, and star is 0 or more of them. So what this does is it'll select any line. That line is then put in a buffer, which you can refer to. That is what the parentheses do. So now I can do open bracket /1. That's the line that I selected by doing this. It's going to enclose it in square brackets for the list, the Python list. And we want a comma because we're making a list of lists. So notice it's now highlighting everything. And I'm not quite sure what happened here, but let's go ahead and see what happens. Okay, so something wasn't happy here. Let's see, but maybe I have a tab or something. No, it got confused. All right, well, anyway, we can fix that fairly quickly. Actually, it's such a minor goof up that we'll just put the brackets in by hand. But it should, in principle, do the brackets correctly. And let's get rid of the tab here. Okay, so the third thing we want to change here, and we'll do Control X space to do the rectangle select. And don't have to worry about this. And then we want to replace the spaces with a comma and a space. So again, I'm going to do the Escape X. I'm going to bring back the query replace regexp one space plus. That's one or more spaces. And I'm going to replace that with a comma and a space. There, I got everything correct this time. I would say that one row here was a glitch of some sort, but in general that won't happen, but sometimes things don't work quite right. All right, so what we've done at this point, so let's understand what we've done. We've converted the text table. The text table came from here. This might be something you cut and pasted from a website, for example, an email you received, something like this. We took this here, and we've converted it into nparray parenthesis and then a list of lists with the actual values. Each row in the table has converted into a list, which is the brackets. Then the rows are separated by commas. All right, so far so good. We've written it, and now I have the shell up here, which you can bring up with the shell command, and I'm going to run this program. And right now it's just a graphics program. All it does is bring up this thing here. All right? So far, so good. Now see, this is the data, and I'm actually seeing this. So this would be maybe the input and the output. This could be a number, for example, of counts, and this could be some value. If that fact, that's what it is, but I'm not going to say exactly what the numbers refer to. And for here, I've just done graphics. That's all I did. But once I've got it in this form, I can do all kinds of data analysis. I can fit models to the data. I can compute medians, modes, the averages, various statistical measures, standard deviation, confidence levels. All the power of Python can now be used by cutting and pasting the actual data into the code. It's all self-contained. I don't have a separate data file. The program is completely self-contained Python program. And that is basically how to do it. And that concludes this demonstration of how to select, cut, and paste a text table into working Python source code using the Emacs code and text editor. This concludes this video presentation. If you like this video, please click like. Please click subscribe and the notification bell if you would like to receive more content from us. You can avoid internet censorship by subscribing directly to our RSS news feed. Please consider sharing the link by email and on your website or blog, in addition to liking, upvoting, or sharing on increasingly censored, advertising beholden, big company social media. We have encountered such censorship. Mathematical software is developing algorithms and software to automate data analysis, reducing the risks of costly errors and increasing the predictive power of the results. You can support our work financially by subscribing on our Patreon page, https://www.patreon.com/mathsoft, or scanning the QR code in the lower right corner.